working with these geniuses. CORViS is a non-profit led by high school students, grade 9 to 12, dedicated to empowering the next generation through STEM, environmental sustainability, and social sciences. We bridge communities and inspire meaningful change through research workshops, on offline and online webinars, policy discussions, and hands-on projects. Today, we're excited to welcome our remarkable guest, Professor Tanveer.
Good day, guys. Here at CORViS, we work to connect young minds globally, fostering a community that thrives on research and innovation. Today, in our session of Speaks Academia, we have Professor Dr. Saleh Tanveer from Ohio State University, and we have segmented our short session today into three parts. And if I have the permission of Professor Saleh Tanveer, I'll start with my segment one about academics and research insights.
Sure.
Okay, so at first, I'd like to dive into some questions about research culture and diversity. So the first question will be, how was the computer science and mathematics research culture evolved over the years, especially in promoting diversity and inclusion?
If you're talking about talents, then it is not limited to geography. We have remarkable examples in history. For instance, in the Indian subcontinent, Ramanujan, he is called the Euler of India. He didn't have formal education beyond high school, and then ended up being one of the greatest mathematicians of all time. So that's an example where you can say that since talent does not know geography, therefore, if you make room for people from diverse backgrounds, you are expected to help the world. Yeah.
That was very insightful, sir. Thank you.
Yeah.
So I will continue with my second question about the same cultural diversity at STEM. So can you share some specific experiences of yours that you have faced in working in the field of STEM, like your personal experiences?
Are we talking about research experience, or
Yeah. As a Bangladeshi person researching and working at the field of STEM in America, the land of opportunities, how was your experience? How did you find it easy? Did you find it challenging? And what will be your suggestions to us aspiring researchers?
Yeah, I mean, the recent phenomena that we have seen is of course aberration. But most of the time, being a foreigner in the U.S., I didn't quite, particularly in the academic area, I didn't quite feel anything different from any other person. My colleagues have always made me feel at home. So by other people in the Bangladeshi community who work in other areas outside academia, they probably feel the impact as a foreigner much more than I did.
Okay, sir. Considering you once described yourself as a mediocre student, what suggestions do you have for us aspiring researchers today who are also not the best at their field, but working to be better?
Yeah, so I always believe, after my experience, that if you actually are sufficiently devoted and sufficiently passionate about what you want to do, then you can succeed at the highest level. The talent is a bit overrated. All talent is needed, of course, so that you don't get frustrated often. All that talent means, the inherent talent, and that's, of course, not something that is fixed at birth. You can grow when you actually put effort into something that expands your mind in ways that you do not quite, it's a very subconscious process. Things which you find difficult at the beginning, if you put your mind into it, it doesn't stay difficult for long. And then eventually it becomes very routine. So in my case, in my early childhood, I didn't pay much attention to my studies. I hated memorization. And that's part of the reason in my early years until fifth grade, whereas all my classmates were memorizing and doing well in exams, I refused to do that and often got punished for not remembering poems in Bangla or English and all these other things. And I couldn't write very well in my early years. So I produced whatever I could write, and I suffered by not getting good grades. But I insisted on not ever wanting to memorize. But then when my writing ability caught up in my about seventh, eighth grade, when I joined cadet college, then I started doing well. And, but I wouldn't say I was that strong. I mean, there are other students who are, um, who did very well in our in our class, and some of them didn't do as well later, even though they started out very well. And I would say that that actually says that if you really put your heart into it and you really like what you want to do, then you can rise. Yeah.
Thank you, sir. Thank you for all of your great insights. I hope that our fellow audience will be very much motivated by the things you just said. So I'll move on to some other questions. So your work spans theoretical computer science, mathematics, and interdisciplinary collaborations. How do you navigate this breadth of inquiry?
No, I'm not. You probably misunderstood. I don't work in the area of theoretical computer science. I'm interested in. Uh, I have what I call a spectator sports kind of interest in machine learning and the mathematical aspects of it. So I have some interest in where AI is going, but I haven't done research on it. As far as physics is concerned, I was always a physicist when I started my career. I'm in college, and I ended up being a double major because I found out that uh, the more the mathematics you have, the better off you are as a physicist. And eventually, I got interested in the theoretical aspects of mathematics and how it connects to physics. And then I found out that I was also, I could apply physics to mathematics in all different kinds of real world problems. So that's how my interest evolved over the years. And then later in my life, I went to more theoretical kind of mathematics, proof-oriented mathematics. But they're driven by applications, even though the nature of mathematics you're doing is more proof-oriented. But it appears you have a problem that comes up in physics and you want to know the answer to a question in a definitive way, then you prove theorems.
Thank you, sir. So my last question for this segment will be about AI. So with AI and other emerging technologies rephrasing our world, which research areas do you see having the most groundbreaking potential?
Yeah,
Sorry, sir. Sorry for the interruptions.
okay. So I'm not particularly knowledgeable about all different things that are happening in AI, but I have a general idea of what's going on. So basically, the most of the problems in AI that come up, if you are going to work in an empirical sense, then these breakthroughs are mostly algorithmic. You find an algorithm to do something quickly, and the mathematical basis is, to me, is more interesting, which is you basically have let me perhaps share a screen, which if you allow me to share my screen.
Yes, sir, please.
I presented this to talk in Buet, but the mathematics is relatively simple to understand, so I might as well. So let me just. You're not able to see my screen, are you? Yeah. Sure. Okay. Can you see this picture?
Yes, sir. Yes, sir. It's visible.
So, okay, so this is an example of a neural network, all right, which is used in machine learning. So basically, you feed in this. So you have all these numbers: input 1, input 2, input 3, all right, and input n. And you take a linear combination of this input and then feed through a nonlinear function, and you call the answer to be H1. So H1 is basically a function of 1, 2, 3, 4, and whatever input you put in. And, oh, what happened? And this, I seem to have lost my page. Oh, oh, no.
It's okay, sir. Please take your time.
Yeah, that's, so, so you can see that you have all these. H1, as I said, is a function of 1, 2, 3, 4, n, and so on and so forth. H2, so you have all these nodal points. This is called the first layer of the nodal points. And these nodal points, the first layer acts as input to the second layer, and so on and so forth. So what has happened is essentially, you have input numbers and you have output, and then that output becomes somebody else's input, and so on and so forth, until you get to the eventual output layer. And what are these inputs and outputs? Well, imagine that you have an image of a cat, all right? So your input are these pixels, which you could have different pixels describing the contrast of the image, or you could have different features. So these so they're then digitized, in other words, converted into numbers, and then fed into through this image. And this input-output relations involve some set of numbers called weights and biases. So these are a set of numbers which characterize the relation between input and output. All right? So at the end, when the output layer comes in, and so you take an image of something, and you want the machine to learn that it's an image of a cat. Machine doesn't know. Machine goes through all these numbers And based on your input output, eventually feeds out an image in terms of pixels. And then it compares against the image of what it should have been. So that's the image of a cat, which has been digitized. And it looks at the difference of these two vectors, the vector of input and vector of output. And these differences are, these differences are, there is something called norm, which is the difference of two vectors. And then it goes through a feedback process by which it minimizes the difference between these two image and output vectors and the desired output vector. All right, so and that's an algorithmic process by which you minimize this distance. And when you have eventually figured out what weights and biases to put so that it reads the image correctly, then you will have said that the machine has learned, right? It has learned. So basically, this idea is relatively trivial mathematically. What is difficult mathematically is to figure out, is to actually prove or like what sort of, how many layers do I need? How many modes do I need in order that it can accurately represent this image or this, or so these are difficult mathematical problems. But at the empirical level, all you're feeding in is numbers of input and output, and you're trying to optimize some function. That's all. Okay.
Okay, sir.
So let me get rid of it.
Okay, sir. Thanks a lot. Thanks a lot for taking your time trying to teach us all this insightful knowledge about AI academia. So I'll pass on the stage to my beautiful co-host Afra for the next segment, segment 2, personal journey and inspirations. Afra, please carry on.
Sir, before I ask you a few questions about your personal life journey, I would like to ask you a small question. What the picture that you showed earlier about the neural network, is it quite similar to how camera works? It inverts the image, the pixels as well. Is it just about the input and output, or is there something where the image also is also inverted?
There are, yeah, what you, no, it's a evolving process. You have to understand. In other words, here it's a evolving process. When you have when I have a camera input output, that's just a fixed process. In other words, that is not evolving in time. So here the evolution happens is it tries to figure out the weights necessary in order to optimize, in order to get the minimum distance in between the two vectors. So it goes through an iterative process. And whereas what you are talking about is a fixed process. You have an input and you get an output. All right, that's a fixed process. Yeah, this is an iterative process. And then you could have a meta programming where this iterative happens on its own. It looks for features and without you telling what the features are. Those are called unsupervised learning. Yeah.
All right. That's an amazing thing to learn. I would like to continue from the second segment, that is your personal journey and inspirations. One of the questions that I would like to ask you are that born into an educated upper middle class family in Dhaka, you mentioned being mediocre student despite your love for mathematics in your early years. How would you describe your upbringing spark your passion for math?
Yeah, no, I was privileged in a way because I didn't, I mean, I didn't, I wasn't, my family wasn't rich, but we felt like we had enough to live off, but middle class parents always worry about what would happen to their kids, and they want to
Yes.
to study things which they think will give give them good jobs. So in that sense, when I wasn't doing well in my early years, my parents were worried because I was really into sports, and I didn't feel like studying, partly because there was so much emphasis on memorization in the early years I didn't like at all. And but then when I went to cadet college, then that really helped me turn around. Yeah.
That I noticed that you mentioned that you were into sports earlier on. So how did you transition from one to other, and what impact did that shift have on your academic journey?
Yeah, in my fifth grade, I was near the bottom of my class, right? Almost. So that's partly because I didn't study, and partly because I didn't like memorizing. And so the strange thing was I failed in 2 subjects out of 12 in what is now Ogroni Balika Vidyalaya, that
Oh,
used to be Azimpur KG school.
all right.
It was until the fifth grade, and then the boys transferred out to. I went to St. Gregory's for a year, year and a few months, and then went to cadet college. So while I was in Azimpur KG school, then interesting thing was that I failed in 2 subjects in my fifth grade, and then at the same time, they gave me a strange thing. They gave me a prize for doing well in math. So, so that's a very strange combination. I
All
liked
right.
math all the time,
All right.
but then so when I went to cadet college, my writing ability caught up, and I did well in other subjects as well. And I was interested in science, and I became very so as I progressed towards cadet college, yeah, until then around ninth grade, for the first time, I came top of my class. I came at the top of my class. So that's but then what happens to young kids, since I was doing well without studying really hard, there was always a like you want to show off as a youngster that you're brilliant. You don't have to study very much to do well. So there was this tendency. But then during the Bangladesh Liberation War, when I was stuck at home, then I started reading. I had access to books, and I started reading a lot of things. And then I realized I didn't know anything. So
Mm.
that period was very transformative. I mean, besides everything else going on in the country at that time, which was horrible, I took solace in one avenue, which was just studying everything around me, not just math and science, but everything. So in that sense, I actually had, just like you people in your generation are finding so easy to access information through the internet. In my time, we didn't have internet, but fortunately, we had libraries close by, and that allowed me to access a lot of information about physics, math, chemistry, everything else, history, how things are everywhere else. I knew about great educational institutions, what they taught at what level. So I knew where I was relative to other students in the world.
Okay. So I see that grade 9 was your game changer, right?
No,
I
no,
think that
it was great. Just during SSC, that's when the Liberation War started.
All
So
right.
our SSC got moved by a whole year. But so during the 9-month period is basically it. There were no the Pakistan Army, they forced us to take the exam, which was then canceled after Bangladesh was born, and then I had to retake the SSC
Exam.
exam again in
Okay.
72. So in 71, but so most of the period we were home and not in school or anything. I mean, we meaning our class.
Yes, yes.
So yeah, so that period, there's not much to do unless you are out there fighting. And I was probably a bit too young for that, but
Yeah.
nonetheless, there was something you wanted to do, and for me, that was reading a lot of things. Yeah.
So would you say that your experience from the Liberation War is quite similar to our experience of um, uh, the things that we experienced back in COVID-19 2019 to 2023 and the recent July uprising?
Well, there are similarities. There are similarities. So there are similarities in the sense that even during the Liberation War, there were some people who had great affinity for Pakistan, whether knowingly or unknowingly, they supported the Pakistan Army.
Mhm.
So in the same sense as, there are people in the society who were, during the current uprising, were very much for either because they benefited or because they actually truly believe, they're true believers in other ways. For whatever reasons, they supported the regime. So the same thing happened during the occupation of Pakistan Army. In that sense, it was similar. The scale was quite a bit different.
Different.
Scale was different because there was not so much in the cities, but the army, when they went around in operations, they would fire indiscriminately, and everybody who had a house in the what you call um, slums, Bosti, around,
Yes, yes,
people were very poor, and a lot of people
yes.
lived near the roads, main roads, near small shacks near the main road. So when the army went on an operation, they would fire indiscriminately everyone who lived around there. And they would always have vengeance when one of the Mukti Bahini killed a few people here, Pakistan Army here and there, and they would go on a rampage. So under those conditions, when you had some within Bangladesh community who, for whatever reason, looked the other way or were actively supporting the army, that created a lot of anger. And right now, the political situation, of course, those people are raising their voices as if nothing
Yes.
happened. But
No.
that's also a lesson because similar things under different slogan, you could have repression. Repression doesn't come under just one, one flag or one slogan. Yeah.
Mm.
Anyway,
I think, yes, I think that has affected our student community a lot in recent times. Moving on, I would like to ask you that starting with a physics honors program at Dhaka University in 1974, and amid family pressure to join BUET must have been challenging. What factors motivated you to follow an academic path?
yeah, so as I mentioned, by the 11th or 12th grade, I was knowledgeable what students learned in different places. So but however, one thing, there was a big gap. I didn't really know that you could do much research in math. none of my teachers in cadet college knew either. So math was what I liked, but essentially there was no one who to guide me about what I could do with math. That there is a field of math research was not something I knew. So therefore, I gravitated towards physics, which I also liked. So physics, of course, everybody knew you could do research because you had an annual prize everybody knows about in physics. So, but in math, there is no prize that people knew about in research. And it is during a time when there was no internet or nothing of that kind. So you didn't have access to what you take for granted right now. So I ended up doing physics and Dhaka University physics during my time. Actually, essentially, until our time, the best students went to physics or economics or basic science. It changed dramatically within about 2 years after, like in my year, the top 10 in board performers, I only know one person out of those top 10 who did engineering or medical school. Everybody else studied either physics, chemistry, or economics. But that used to be the case in Dhaka University. So the Dhaka University Physics Department has always attracted the top students. And for me, it was more than that because I already knew I liked physics and so my transition to math happened when I came abroad, and then I found that I could understand physics, but as I studied on my own, the only barrier I had was following the mathematics. So when they did in the physics department, when they introduced us with math, I wasn't very happy because I would ask very basic questions about the mathematics. So for instance, there is something called Fourier series.
Yes.
And so they used the Fourier series in all kinds of problems in physics. And then so they had something called convergence in the mean and all these things. So I said, what is all this? What are all these things? And pointwise convergence. And so then I realized that to understand what really it is, you have to understand a lot of basic math. So I started then. That's after I came to Pomona College in California, after about a year, that's when I started taking math classes, proof-oriented math classes. So that's where transition happened from physics to math. But I was a double major, so I did a double major in math and physics, and I also had a master's. Yeah.
That's exactly where the next question leads to, is that after completing a double major in mathematics and physics, earning a master's from Claremont Graduate University, and beginning your PhD at Caltech, how did these diverse academic experiences shape your career, sir?
Well, in a sense, when I learned math and physics, when I came to Caltech, part of the reason I came to Caltech was because Caltech Applied Math Department was very open. They allowed people to have advisors in any department you wanted. So I wasn't sure I was going to pursue more physics or more mathematics or what. So I was a confused person. So when I entered graduate school, so I thought I might do something with Kip Thorne because I took a course from him on general theory of relativity. Thorne later won the Nobel Prize in 2017. So I pursued relativity with him, and I took also a course I started a course with Feynman
Yes.
on graduate course on quantum mechanics.
Yes.
So I was taking physics courses, and then I was deciding as research area either quantum mechanics, relativity, or fluid mechanics. Fluid mechanics was done quite physics-oriented math at that stage. We had, in my department, I had a well-known person in that area. So I didn't have to choose an advisor outside the department. So in applied math, we had a person who was an expert on fluid dynamics. So I chose fluid dynamics for a research area. So there, during my PhD, it was much more oriented towards trying to understand the physics of the fluid and doing calculations to support this is what's going on, this is what's going on. So it was very similar to how a physicist would approach the subject.
Mm.
But later on, over my career, I started becoming more and more pure oriented, meaning more theoretical oriented, where I wanted to prove theorems. So at the beginning, I was using like computational methods where I used computers to get my calculations. These are very old-time computers that take forever. What now takes less than half a second would take me more than a day to calculate. But that's the skill I learned early on to actually do numerical calculations of partial differential equations and things like that. Yeah.
Thank you, sir. Your every word you say is so inspiring to me, and I myself am someone who struggles in mathematics but loves biology and chemistry and physics, the theory part. So I myself can see that I'm getting motivated by you every second. So, sir, for this instance, I would like to ask you in this for the last question in this segment, that is that you've been a staunch advocate for enhancing mathematical research and in education in Bangladesh, voicing
Mhm.
concerns that lacking talent might hinder national progress. Do you believe
Yes.
talent is the only sole ingredient for success, or do you think that other elements play a critical role as well?
Yeah, it's a multifactorial. There is no easy explanation. Of course, if the political interference in the university administration we have seen over many regimes since Bangladesh's independence,
Yeah.
if we didn't have it was run more professionally rather than by political hacks, we would have a much better education outcome for sure. If professors are more interested in building their career through political connections and trying to become VCs here and there, that's not a good environment for students to thrive in. So, and the other part is the administrative structure is, VC has a lot of here, as I see in the United States, in our universities, the administration, nobody, I don't have to see the VC to get anything done. There is well-defined, I hardly ever see my department chair. I do my own thing, and responsibly, of course. And there is the administration doesn't hinder or what I want to do. So that's a big difference. Whereas in Bangladesh context, we have people jostling for favors
Yes,
uh, from
exactly.
from people who are higher up, And that creates a bad situation, because then even if you're very talented, you can't survive in that situation, because you look for opportunities elsewhere.
Exactly. That was so point on and so relatable actually. So what are some of the initiatives or changes that you would like to add and to be
No,
seen?
despite what doom and gloom, there are
Yes.
some good things. There are some professors I respect who are in Bangladesh, and despite the very, very negative atmosphere, they're
Yes,
doing
yes, yes, of
a
course.
tremendously good job. I admire them, and they're the pillars who need to be need their paths have to be made easier.
Yes.
And I also feel like there are a lot of you who will come abroad. That's a given. India at this stage, when I went to Caltech, most of my students were from from fellow students were from Indian Institute of Technology, one or the other IITs. I didn't know anyone who wasn't from an IIT. And at that time, the saying was that Nehru created these IITs just to help America and the West, because none of these people are coming back. We are at that stage in Bangladesh right now. However, uh, when you have a few people in Bangladesh and they're basically emboldened, if you create an atmosphere where the administration emboldens the few people who are trying to do good things by removing the barriers that they're facing, then what happens is you could start uh, creating partnership with institutions abroad, and through which your students, your meaning the professors who are there, who are working on the ground, their students can then be connected to other well-known people across, all over the world, and that opens up their opportunities. So I have been thinking that perhaps a mathematical institute, where of some kind could be constructed outside the academia, which actually doesn't have any permanent faculty. What you have
Mhm.
is a small core director and a deputy director, and then you have programs for a few month period where you host a program in this particular area, and then faculty in Bangladesh, they are asked to actually write proposal for, to so where they will ask for money for supporting some sabbaticals from universities all across Bangladesh. And then they will have foreign visitors going there, giving talks from, and that way you have this atmosphere where also students participate. And that is an ideal way of actually getting the level of our universities, making it attractive, and also the best talents of Bangladesh can actually be more connected to Bangladesh, instead of right now the only avenue you have is you come back to your university. Hopefully you're not mistreated. Hopefully you stay there enough for long enough to make an impact. And that's a very tall task. If you had an institute that was functioning in the way then you have a better chance of retaining some of the best talents we have.
That was an amazing explanation to uh, bring back our talents back in our own country. So, sir, we would like to um, move on to the next segment and the last segment in this discussion. That would be, sir, your spotlight. We would like to make a spotlight on your research contributions, which is one of the questions would be that your work has advanced computational models, algorithm design, and network theory, paving the way for innovative transportation, communication, and machine learning solutions. Could you share one or two key projects
No,
of
no,
breakthroughs?
yeah, you may have misunderstood what I said as what I talked about machine learning. As I mentioned earlier, I don't work in this area, but I find that is a simple, good example to give to people entering math, because entering math, this shows how mathematical thinking pervades all the modern developments. You know, in the computer science itself, there is there is a Alan Turing prize given, as a Turing Award given every year is the highest prize in computer science. And Alan Turing was a mathematician, in fact, a logician. And so Nash equilibrium is an important concept in economics. And Nash equilibrium was the creation of John Nash, it was basically his PhD thesis. And John Nash, probably you know the person because he had some mental problems, and there was a movie made about him. I think it's The Beautiful Mind or something.
Yes, yes, yes.
Yeah.
Exactly.
So this John Nash, when people came over to say you're going to get the Nobel Prize, then he said, I did much better things than this. So he was very surprised that he was being awarded for something that he had done during his PhD, because he had done much more higher level mathematical work. But as far as applications is concerned, that was a major application, and it changed a lot of things in the way economists thought about it. And he got the Nobel Prize in economics. So my point about mentioning some of these applications, which are outside my expertise, is just to tell people that, you know, things that you know that are not necessarily from the mathematical side actually have their origins in mathematics.
From mathematics, yes.
And AI is one of those areas. I actually
Mm.
my research is mostly in fluid dynamics.
Yeah.
So I also have done some work in quantum mechanics, and some work that just a small amount of work, which is quite kind of theoretical, very theoretical oriented in having to do with properties of so-called integrable differential equations.
Mm.
So in fluid dynamics, I don't know, there are different aspects of fluid dynamics. One is, how do you describe the boundary of a fluid which is evolving in time,
Mm.
right? So basically, it could be drops or bubbles. It could be water waves.
Mm.
So these are called free boundary problems in fluid dynamics. So I'm interested in those.
Mm.
I've contributed, you know, quite. I mean, whatever little I have done, a lot of it is in that area. I also am interested in the theoretical questions about solutions to Navier-Stokes equation, which is the so-called mother equation of all fluids. And so that is there are theoretical problems in that area. And I also did work on quantum mechanics, where we tried to, we extended the work of Enrico Fermi. Fermi was a well-known physicist, and now he did a lot of different things. One of the things he did was ionization. So if you actually shine ionization is, you know what ionization is? You have an atomic structure
Yes, yes, yes.
and you want to disassociate the electrons from the
Yes,
protons and neutrons. That's called ionization.
yes.
So imagine you have a molecular structure or atomic structure, and you want to ask the question if you put in a laser field,
All right,
so it has a certain frequency. Will it ionize? Right?
all right, all right.
So basically, in terms of mathematics, what that means is you go back to Schrodinger equation. Schrodinger
We
equation
Yes,
is
we've learned those in our higher secondary levels
okay.
recently.
So in the Schrodinger equation, you want to there is something called time dependent Schrodinger equation and time independent Schrodinger equation. So time dependent Schrodinger equation, you have to, this is basically a partial differential equation in a
Yes,
complex, it's a complex differential equation, meaning it involves complex numbers.
mm,
And this complex partial differential equation, the question that we answered is if you actually have a radial oscillatory field
yes,
on top of a Coulomb potential. Coulomb potential is basically the attraction. It models the attraction of the
right,
nucleus
yes,
with attraction of the electron and nucleus. So that's
yes,
called the Coulomb potential. And
yes,
then if you have a radial magnetic radial oscillatory field, then in
yes.
the Schrodinger equation, you have to put it as a time-dependent potential.
All
And
right,
then the question that we answered is what would happen if you started out an uh, arbitrary frequency oscillation of the laser field? Will it necessarily ionize? Right?
all right,
And ionization can be cast as a mathematical property, and so you can anyway. So I don't want to go too technical. So we addressed that question
all right.
in quantum mechanics. Yeah.
Thank you so much, sir. A lot of those words were quite remarkable and memorable from my own studies, but I couldn't recall the entire definitions. Thank you so much for going down through the definitions as well. Moving on to the next and last question of this segment is that what are the most memorable or unique honor or awards that you've received, and why does it stand out for you, sir? Since I've seen
No,
that you have quite a
it's
lot of awards
no,
in your.
it's yeah, yeah. I mean, I got an award in 1987 by the American Physical Society for a best paper contribution in a journal, well-known journal. So that was probably uh, I got other honors like I was the Simons Fellow at the Isaac Newton Institute at Cambridge University more recently. And then I was also an elder fellow at Imperial College about 2 years back. So
Oh,
those are small honors. And then I guess I was what else? Yeah, yeah, Bangladesh Academy of Sciences, you know, made me an expatriate fellow. Yeah.
all right.
Mm.
So thank you, sir. Thank you so much for answering all of my questions. I would like to pass the floor to my co-host Aryan Zaman for the next and concluding segment. And thank you, sir. It was a pleasure to talk to you. Okay, thank you.
Sure.
Aryan?
Okay, I'll like to carry on. So for the closing remarks, I'll like to ask you a little bit about your future visions. So this question's about balancing passion and profession. As we wrap up, could you offer any final thoughts on balancing personal passion with professional ambition,
Yeah,
specifically in
yeah.
the
I suppose the the part of the reason why I worry about uh, the mathematical training is I don't know if you have seen any of my YouTube talks, but I actually emphasize that if you have I'm first talking about national needs, then I'll come down to your question. So I feel that there is a huge need to improve the level of mathematical training. You don't have to be a mathematician, but you have to be trained in enough math so that you could attack problems in engineering and computer science at the highest level. And without a sound mathematical training, we are actually in Bangladesh, we are shortchanging our kids. Right? And part of the reason we don't have adequate mathematical training of our engineers, even at BUET and the best place in engineering and things like that, part of the reason is we don't have enough talented people entering mathematics and basic sciences. And that is creating a vacuum, sort of a vacuum. We have a few extremely good people, but not enough. And this is where you see our parents and everyone around, they think, what are you going to do if you study math or physics? And what career do you have? And most people you talk around don't think anything about math. But that's the situation in Bangladesh. But here in the US, even in my university, there is a huge number, a record number of people entering STEM disciplines, including mathematics. And a lot of them do not end up being mathematician, but you see, this training is considered vital because when they want to enter, in fact, even law schools, medical schools, they prefer students coming from hard, quote unquote, hard sciences, right? And part of this reason is this, that in math, when you actually do math properly, not just memorize formulas and do computations and do elimination here and there, when you actually learn it properly, it's really a training about going from point A to point B through a sequence of logical exercise. Yeah. This process by which you actually go from point A to point B through a sequence of reasoning, that is a talent and that is a skill that is transferable to whatever area you want to go to. And that is quite well understood by our employers in the US, whether it's in banking or whether it's in graduate school in other areas. Our students are going to data sciences. They're becoming actuary. They're going to statistics. They're going to biostatistics. They're going to biological science to do biomathematics. They bring in skills, and they're going to, topological data science in big data systems. All of them emerge from the students that we actually guide. And in Bangladesh, there is a big, big scope of any of these areas. Yeah, but you cannot. This whole idea, and see, it becomes a chicken and egg problem, basically, because people don't think you can do much with maths training. As a result, we have, on the average, lower level students than there should be in the mathematics discipline. And I'm saying the same thing with physics and other chemistry, all basic sciences. We don't have enough talented people going in there. When you don't have enough talented people going into those areas, then what happens is you don't have good enough talent to teach you, even if you're in some other discipline. So you're shortchanging the career paths of a lot of people because you don't have enough talent. So if you, now I'm going to the personal side about a student trying to decide what to do. Keep in mind that if you do well enough in any discipline, the sky is your limit.
Yes,
Of
sir.
course, the level at which you have to do well enough is higher in a very competitive area. That part is true. But on the other hand, I want you to know that I didn't start off as a particularly like standout student of any kind. Yeah, I was good in math, but a lot of students are good in math in the lower classes and so. But what matters is your passion. And if you really actually pay attention to that, so I would also ask the guardians who are less informed about what is available to actually know that if you study a basic subject like math and physics. I ended up getting an engineering degree at Caltech, even without being in the program. And it was only possible because I had such a strong background in math and physics. So everything else came very naturally to me. So I was taking some classes, random classes in engineering, and I made the mistake of telling my father that, he wanted me to be an engineer in the first place. So I told him that I'd taken so many classes. He said, and then he got excited. He said, go finish your engineering degree. So that's what I did, but I never wanted to be an engineer. But the point is that my point is that if you have enough of the basic sciences, understand it well enough in physics and math, then everything else comes very naturally, all right?
Yes.
And you did not pursue. In fact, many students in Bangladesh don't quite understand this. You could be trained in math and you could go and do a PhD in engineering, in applied mechanics, in a different area, all right? You don't have to pursue mathematics. But if you're well trained in math, it opens up opportunity in many different disciplines. And I should say math as well as physics. Those are the core subjects.
Yes, sir. Thank you. Thanks a lot for all these great insights. So I will try to conclude this session with my final question. So what legacy do you want to leave to in this academic world? With last few words, can you please describe the legacy you want to leave in this academic world? Sorry.
Yeah, I mean, we have to be modest. I mean, each of us, I don't particularly have a big legacy, but I have a few students who have done well. They're professors at well-known places. One is a professor at University of California, Irvine, and another is a professor at Imperial College. So those are the two of my best students. And as far as other things, I basically think that you people, you youngsters in Bangladesh who are living this time, despite all the negativity around you, the opportunities that you have are incredible in terms of what is possible. You can leapfrog your teacher's limitation quite easily, if only you actually exert yourself and find out what are the things that you need to know, what are the things that if you open yourself up to the same kind of exploration that I had done earlier on, if you want to ask me about my legacy, I would say that it should be basically that I'm an example where if you actually learn something well and you're sufficiently motivated, particularly in the modern world, that would actually, you would be able to get to much bigger heights than we ever could. All right.
Okay, thanks a lot, sir. Thanks a lot.
Sure.
Your insightful words of wisdom means a lot to us. And we, as the new generation from Bangladesh, from Dhaka, and all over Bangladesh, want to be like you, make, uh, want to leave a legacy for the world. So thank
Mhm.
you for being with us. This was glad for us to host you in this session of our Speaks Academia today. So I'll like to pass on the stage to Afra for her concluding words.
Thank you so much, Arin. My final words for Sir would be that it's always the greatest minds who are the most humble and down to earth. I think Sir has so much knowledge inside him, and yet he tends to make himself look so and sound so relatable to him, although he's so amazingly wise person. And I am truly motivated and inspired by you every minute. So we truly appreciate your time and wisdom, sir. To our viewers, we hope you leave and inspired and ready to embrace your academic adventures. See you next time. And thank you,
Okay.
sir, once again.
Okay.
Thanks a
Thank
lot.
you very
Thanks a
much.
lot to the
Thank you.
professor.
Thank you. Thanks for your kind words. Yeah. Okay. Bye bye.
Thank you. Assalamu
Okay.
alaikum, sir.
Okay,
Walaikum salam.
lastly, I'll thank our audience, a lovely audience, for being with us. Thank you, everyone, for joining with us. Until next time, keep exploring, keep innovating, stay with CORViS. Bye bye, Assalamu alaikum, and thanks a lot
Uh,
again to the
okay.
professor.
Okay.
Okay,
Okay. Assalamu alaikum.
Assalamu alaikum. Walaikum.